Hey everyone, welcome to today's lesson. It's going to be, this is pretty much we're approaching the last lessons on calculus, okay, on the introduction to calculus. So this, in my opinion, should be even easier than the previous lessons because it's very, very visual and you just, and in the next slide, you're going to use area of a rectangle, which is something you learned in like fourth grade, okay? So here's the idea, okay? Let's say we are trying to estimate this area right here, okay? Let's say we're trying to estimate that area. Okay, let me erase this portion here. Okay, ignore this part with the yellow part sticking out. We're looking at what's below the curve to the right of the y-axis and above the x-axis. Okay, so let's say we're looking for that area. Okay, now that's a really, really odd shape. Okay, that's a weird shape that we got over there. Okay, there's no set way. You can't use a formula for a rectangle, a square, a triangle because it's neither of those shapes. Okay, so what they've done in calculus is figure out a way to estimate the area. Okay, so let's say we have 5 rectangles right here. Okay, and we do length times width of each rectangle and add up all 5 rectangles. You will get some sort of estimation of the curve, okay, of the area below the curve, okay, that matches the yellow highlight. Now, if we make more rectangles that are narrower, okay, like you see here, then you will get a better estimation of this yellow area here. Okay, so long story short, the more rectangles we draw that are narrower, okay, underneath this in this yellow region, the closer we get to a better approximation of this yellow area. Okay, that is the key point that I want to drive home. Okay, now the second and should be last slide. Okay, let's say we have this curve right here. Here's the equation of the curve. Okay, here's the equation of the curve. Now, and let's say we have these 5 rectangles. Okay, let's say we have these 5 rectangles. So the width of each rectangle is 0.5. Okay, because this is 0, 0.51, 1.52, and 2.5. Okay, so I am going to go. Now, I'm going to figure out the area of this first. I'm going to figure out the area of this first rectangle right here. Okay, that is going to be 0.25, whoops, 0.5, excuse me, times, okay, the height of it, which is 4. Okay, I'm just looking at it and it's 4 right here. Okay, now what I wanted to say was, well, let's keep going. Okay, and then I am going to go plus. Let's do the second rectangle here. 0.5 times the height of this rectangle. I'm going to estimate that to be. I'm going to estimate that to be 3.75. Okay. Now this estimation in this case, you can plug in 0.5. So if I want this green dot right here, okay, we're working on the height of this second rectangle. If I'm looking at that green dot there, okay, if I want to find the exact height, which you should be finding the exact height, you can plug in 0.5 to these x's, okay, 0.5 to the x's, and then it will spit out the y value of this dot, which should be around 3.75. Okay? All right. So when there's an equation available, okay, when there's an equation, this is the key point. If there's an equation available, plug in, okay, plug in the x value, in this case 0.5, to find the height of the rectangle, which is around 3.75. Okay? Sometimes there is no equation available. Okay, sometimes it's just the graph. If it's just a graph, just estimate it. Okay, so I'm not even though there's an equation here, I'm not plugging the equation because it's just too much work right now. Okay, it's just I don't want to waste your time for you watching me plug in these numbers. I just want to get straight. I want to get straight to the point. But if there's an equation available, like you see right here, plug it in. Okay, and now let's bounce on over to this dot right here. Okay, let's bounce on over to this dot. Okay, again, the width of that rectangle is going to be 0.5 times, I'm going to estimate that to be 5 point, let's just round it off to 5.5. It's a little bit under 5.5. Okay, now again, if you want to find the exact coordinate of that, okay, because the equation available, in this case you would plug in 1, okay, because the x value of the start of this rectangle, okay, the bottom, the x value of this guy, okay, the x value of this guy is going to be 1. Okay, actually I'll just go like this. The x value of this dot is going to be 1. Okay, so you plug in 1 over here and it'll get you something a little bit under 5.5. Okay, likewise here you would plug in the x value of 1.5 to get the y value of this guy right here. Okay, all right, let's keep going. All right, and I'm gonna go plus. Let's go on to this fourth rectangle. The width is 0.5, and the height is roughly. Okay, the height is roughly 5.5. Excuse me. It is 5.5. I made a mistake here. This should have been 4.5. Okay, times 5.5. Okay, and the same is going to go for the last rectangle. It's going to be plus 0.5 times 5.5 again. Okay, and then you just just literally put this in your calculator and you get the answer. Okay. All right. So you're going to have some problems where the equation is not available. You're going to have some problems where this is not available. In that case, you just visually estimate it, just like we did here. You're going to have some problems where you have an equation, which means you have to plug in the x values, okay, of these dots to find the y values of which are the height of the rectangles, okay, to get an exact height, okay, versus an estimated height when there is no equation. Okay. Now, this is called what we just did is called left rectangular approximation method. Okay. The reason it's called left as opposed to right, if you look at these dots, they're on the top left of each rectangle. So the first thing you do, okay, is draw dots, okay, I like to draw dots at every interval here. So a dot here, every y interval, I should say. Here's a dot here, here's a dot there, here's a dot here, there's a dot there, there's a dot there. And then you draw rectangles, okay? You draw rectangles that touch, okay? So let me ungroup this. Okay, I'll put it like this. You draw a rectangle that touches, where you draw a rectangle so that the dot touches the top left. Okay, you draw a rectangle so the dot touches the top left. Okay, right there. Okay, another one here. Another one here. And another one here. Okay? Now, right rectangular, okay, is going to be where you do the same thing, okay? Draw dots, okay? Draw dots, and and then you draw rectangles where the dot touches the top right, okay? So here, okay, here it touches the top right. The dots touch the top right of each rectangle. Here, here, and here. Okay. Now this rectangle is actually not going to count because this is not within the yellow area that we want from the previous example. Okay, this is not within the yellow area here. Okay, this rectangle is outside of it, so we don't even care about that. Okay, so now let's go ahead and do right rectangular. Okay, again, it's 0.5 for the width. Let's look at this first one. Okay, and it is roughly 3.75 for this first rectangle. Okay. The second rectangle is, again, same width times the height of it is going to be, height of it, again, let's estimate it. I'm just going to estimate it just like we did before to be 4.5. Okay, it's going to be 4.5 here. I just made that a little higher. I cheated a little bit. Okay, just to make this example flow a little smoothly, more smooth. Okay, let's go to this third rectangle, 0.5. 0.5 times this height is 5.5, and again it's the same idea for this one right here. All right, plus 0.5 times 5.5. Same one for that one here. So right now, as of right now, we are, okay, on this dot here. Okay, we just finished these two, which are these two. Okay, right there. All right. Now, pay attention to this last one, folks. Okay, this last one, which is right over here. Okay, this guy right here, your width again is 0.5. Your height, however, your height is 0. Okay, I drew this rectangle here with a little bit of a height above 0 because I just want you to see that there is a rectangle to be drawn just so that you can prove you know what you're doing. Okay, but realistically, the height is 0. Okay, so it doesn't really count as anything. All right, and these two will give you an approximation. Okay, these are two different methods for giving the approximation of both areas. Okay, both of those yellow areas. All right. Now, which one is better? I don't want you to think of what's better and what's not. What we're going to end up doing is, at some point, is we're going to take the average. We're going to get whatever answer you get here and here. You're just going to average them, add them up, divide it by 2, and that's going to be the more accurate one. Okay, so you'll see that. All right. All right, folks. Well, I think that pretty much wraps up today's lesson. Okay, I want you to do these problems and do it in this order. Okay, that you see 11 and 12. Okay, there's no well, actually, there is an equation. Okay, and you remember for these dots here. Okay, if you want the exact y value, okay, if you want the exact y value, plug in the x value. In this case, is -1, and it'll give you the exact height of the rectangle. Okay, same thing for this guy, same thing for that guy, same thing for that guy. Plug it into this equation right over here. Okay, to find the height of those rectangles. And the interval here, that each width of the rectangle is 0.5. Okay, when you get to 17 to 20, okay, the width of each rectangle is going to be a nice clean 1. Okay, it's going to be a nice clean 1. Okay, and you're going to use Desmos to graph it. Okay, and just copy down the graph. Copy down the graph once. Okay, to do the right estimation, RAM. Okay, and then copy down the graph another time to do LRAM. Okay, so you're basically, for 17 to 20, you're basically doing this. Okay, copying the graph twice. Okay, you're doing this whole thing right here. All right, and then you average the two. All right, and again, they give you equations, so plug in the x values so that you can get the exact heights of the rectangles. Okay, 7 and 9, there are no equations, so these are just purely estimations. Okay, you just purely estimate the height of each rectangle, and I want you to do right RAM estimates and left RAM estimates. Okay. All right. So here I did left RAM first, right RAM second. Here I reversed it. Okay, it doesn't really matter. Honestly, it doesn't really matter what order you do it in. Okay, folks, that wraps up today's lesson. Thank you very much for tuning in. Have a great rest of the day.